Before we finish the notes, one thing I want to remind you, this is the first page of your note packet. This is one good way to start preparing for a quiz or a test. It has two things that are helpful. First, it has everything that you should know how to do, all the objectives. It also has at the bottom what you need to know how to do on the calculator. So if I were you, I would just take a quick glance through that list and make sure you know how to do everything on the calculator. This is where we left off. So if I could have you find this page. First thing that we're going to talk about, which you got a little bit of a preview on in your homework, is a residual plot. We already talked about the first thing you're going to do is you graph your data and you look at your scatter plot and you say, yeah, it looks linear, or no, it doesn't. Then you might calculate R. It can be a little subjective though. I might look at a scatter plot and think it looks linear, and you might think it won't. A residual plot is just another tool to address the form of a relationship. So it is a way for us to better determine, is the relationship linear or curved? Or maybe there's not a relationship. What the residual plot does is it's a scatter plot, and it plots every x versus the residual, or it might do y hat versus the residual. So just remember, for your data, you have x comma y. So for every data point, you would calculate a residual. You then would construct, the graph you saw in the homework is the x value versus the residual for that point. And you'll have a whole bunch of them. What you're going to look for in a residual plot. You are looking for any patterns and the size of the residuals. Okay, so here's the deal. If we think about, we have some type of data and we fit a line of best fit to it. Remember, the residuals are the errors in the y direction. So these are all of the residuals. So you'll notice some are positive. The ones up here are positive. They're above the line. The ones down here are going to be negative. So in your residual plot, you will see both positives and negatives. The form of your residual plot this is just a basic idea, is whatever the association is, take away the model, which leaves those red. So take your original data, fit the model to it, pull that model away. That's what you're left with in the residual plot. Okay, here is the big deal. A good linear fit. So if you fit a line to the data and it is an appropriate fit, you will see a random pattern in the residual plot. It'll just look like a random scattering of points. And then just as a reminder, we cannot use R to assess linearity. So just because R is 0.97 doesn't mean that the data is linear.
Because there could be some outlier that's messing everything up.
Could be an outlier. It could be that a curve would be a better fit. One thing we have to be able to do is construct residual plots. We didn't keep the candy data, so I took this data from the previous page. What I need you to do right now in your calculator, put outpatient care in list 1 and put inpatient care in list 2. And there should be 11 pairs. Okay, we got all those in list 1 and list 2? Real quick, I want to make sure we remember how to do a few things. First thing I want you to do right now is calculate R and the least squares regression line. So do that right now. Calculate R and the least squares regression line.
Okay. Okay, what buttons?
Can anybody verify that they got the same values I did? Thank you. Okay. We should just be going to stat, calc, linear regression. You did that? Okay. Once you've calculated the line of best fit, you have to do that first. Once you've done that, the calculator has all of the residuals for you. You just have to find them. So right now, click the same buttons that I'm going to tell you. Hit second list. Second list. And on your calculator, it should say L1, L2, L3. Do you see that? Okay, scroll all the way down.
Wait.
Second list.
Second list.
And scroll all the way down, and you should have this list named Resid. Hit enter and hit enter one more time. Those are all of the residuals. So you should see the first one, 1.322. The next one is negative 7.825, so on and so forth.
How do you make it? How do you make it show you more?
Okay. Do we all have the residuals?
I have.
Okay. Yeah. If you want to see them in an easier fashion, so you don't want them listed horizontally, just hit stow, and I'm going to store them in list 3. And so now when I go into list 3, like I go to edit it, I'm not going to edit it, but I go into list 3, I can see all of my residuals. Can you check in with the people around you? Can you just show your calculator of residuals? Because I know some of us are lost.
How do you make it? How do you make it appear?
How do you make what appear? Okay, so you didn't store it.
I have.
You have to put stow
and then a letter.
list 3.
Oh, so I need to get back to that. So that.
What? Yeah. Okay. Are we all good? We've looked at our list 3. We have all of our residuals. Yes? 2 I want to do. I cannot stress enough to you that this list is based off of the last time that you found a line of best fit. So if you would go change your data right now and go to the residual list, it's going to be exactly the same because you have not done a new regression. The other thing that I want to make sure that we remember how to do is that we remember how to look at a scatter plot of the data. So if you go to second stat plot and turn your first plot on, right now we're choosing a scatter plot of list 1 versus list 2. And then does anybody remember what we do before we look at the graph? Like how we reset our window to fit the data?
Zoom 8 or Zoom 9?
Zoom 9. So do Zoom 9. And then show your scatter plot to the person next to you. Make sure you guys have the same scatter plot.
Is there a way you can figure out the values of the points on it?
The best I have.
Just like drag it, right?
That's all I have.
This is the residual.
Close.
Sorry, I don't
Well, it's just like if you want a basic graph.
Okay. Are we all looking at a regular scatter plot right now?
Yes.
Okay. You should notice on your scatter plot that most of the points follow a line, and then you have one that kind of doesn't. It's an outlier. It's far off in the y direction. Is that point going to have a heavy influence on this line?
No.
No. It will have some influence, not a heavy influence though, because it's just an outlier in the x direction. We good so far? Okay. Here is the last thing that I want us to do. The last thing that we have to do right now is actually construct the residual plot. So what you're going to do is you're going to go back to stat plot. This time, your X list is going to stay L1. That's your X's. And your Y list, we need the residuals. So you have two options. Either you can use list 3 if you put the residuals there, or you can just put in the resid list, whichever one you prefer. So do that now. Change that Y list, and then again, you're going to do Zoom 9.
What?
Show your residual plot to the person next to you.
I think that was messy.
Prefer residence and just so I don't forget to not change it then.
What button did I?
You get that same?
Exit.
Yeah, right. So you go here. Yeah. So wait, I'm gonna go. I go to stat plot. Click on this. And you change list 2. And then you change it to either list 3 or residual.
Yep. And then I can.
This is the residual plot that I have.
Yep.
You have one like this in your homework, just sketch it off the calculator. I don't even really need labels. All I care about is you just sketch what you see. Okay. Anything we need to review on the calculator or anybody having issues? Because if you do, now is the time to ask. The last part. I went to stat plot again. Yep. No, sorry.
Just need to put it on the calculator, bro.
All we need to do is change that Y list so we're down to that. So what I did is the second list. Go down,
The same
find
people who
that.
make these Texas instruments also anti-tank missiles.
And then you'll do
Same people who make these make
Okay.
anti-tank missiles.
Everybody else, okay?
Yes.
Any other issues?
Crazy.
Okay. Some things that you should notice.
This.
This is a residual of 0. So these residuals are all negative. These residuals are all positive. If you were asked to interpret this like we do here, you would talk about, first, this point is a really large residual. If we ignore that point, so if we ignore that point and just look here, we're asking ourselves, is there a pattern of any kind? The points should be scattered randomly, about half above, about half below. We can see that it looks like there are more negative residuals than there are positive. Besides that, though, there's no real pattern. The biggest patterns we're concerned of are a curve, or what is called a fan pattern. So we'll write those down in a minute, but we are concerned about a curve or a fan pattern. So if you were asked to interpret this residual plot, you would say something like, there is one observation with a large residual. The remaining observations are scattered, showing us that the linear model is appropriate. Do you want me to write that down, or was saying that enough?
Saying it was enough.
Saying it's enough? Okay. Ooh. Okay.
Have you tried just maybe scrolling with your finger?
Yeah, that's what I tried. Oh, there we go.
Yeah, sometimes it.
Okay.
Usually the iPad can differentiate between the pen and your finger, and sometimes it really gets annoying about it.
Here are the two patterns that I want to make sure that we look out for. The first one is a curved residual plot. If there is a curve in the residual plot, that tells us that the original data is likely curved. So a curve in the residual plot means that the original data is likely curved. And then the second pattern that you're going to look out for is a fan pattern, which tells us that the linear model is not appropriate. When I say fan pattern, it literally looks like a fan. The residuals are close together and then they fan out. So that would be something like residuals close and then they get much further apart. Here's why that's an issue. If we think of the idea of a residual, what this tells us then is these points in the beginning are close to the line, and then progressively they get further and further away from the line. So hence the linear model is not appropriate. There are other patterns as well, but those are the two most common ones. Okay. We have two more things to talk about. I'm going to try to be quick, though. We're done with the calculator for right now. Questions before the last two things? Okay. I'm going to skip around a little bit. The next thing that we're going to talk about is standard deviation of the residuals. Sometimes it uses the symbol S. Sometimes you might see SE. So either one of those refer to standard deviation of the residuals. Standard deviation, we remember, is the typical deviation from the mean. SE is the typical residual. It's the typical residual. So it's typically how far the actual values differ from the predictions. You are not going to have to calculate this. You are just going to have to interpret it. Let's say we're still using the hospital data. I don't know what SE is, so I'm just going to say it's 7.2. If we were asked to interpret this, we would say typically the observations in inpatient care, in parentheses, I'm just going to clarify, that is the Y variable. So typically observations in the Y variable differ by 7.2, whatever the units are. I don't know what the units are. From the predicted inpatient care. So typically observations in Y, the actual Y, differ by 7.2 from the predicted Y. We have to make sure we mention what we're using when using the least squares regression line between X equals outpatient care and Y equals inpatient care. Questions on that? I just need 5 minutes. I'm sorry, I told you this was going to be 15 minutes. Obviously, I was wrong. Can I have 5 more minutes? Yeah. Questions on that before the last thing? Okay. Hopefully, we've noticed as we've been calculating the line of best fit, have you noticed the last line is R, but before that, you always get R squared? And so maybe we've been wondering why? Why do we have R squared? Well, first of all, R squared is called the coefficient of determination. So when you see that term, that means R squared. R, on the other hand, is correlation coefficient. Okay. So what does R squared mean in simple terms? In simple terms, R squared is the percent of time that Y changes because X does. So the data set that we were just looking at, the hospital one, R squared was 0.5. So that means 50% of the time Y is changing because X does. The other 50% of the time, Y is changing for some other reason, called unexplained variation. This is the sentence I need you to memorize. I don't want you to get creative. I don't want you to interpret that way. That is the simple terms if you were talking to somebody who was not in a stats class. What you're going to say, if you're talking to someone in a stats class or doing this on a quiz, you're going to say 0.53 of the variability in inpatient cost. That's the Y variable. So 0.53 of the variability in Y can be explained by the least squares regression line between X equals outpatient care and Y equals inpatient care. I just have one last question I want to answer, and then we will take a break. It is essential to use that word variability, and it is the variability in Y, not predicted Y, not X. Variability in Y, just plain old Y, the actual Y values. Last thing I want to address is how R squared is related to S. Both measure how well the line models the data. But big difference is units. S has same units as Y. R squared has no units because it's just standard. Neither of them address form. The only way to look at form is to look at a graph. The original scatter plot and a residual plot.